Hello friends, today we are going to solve the problem on shear force and bending moment diagram. Already I have taken few problems on SFD and BMD. Here the important concept, if the moment will be given to you, then how to draw shear force diagram and bending moment diagram. See, in this diagram, moment is given. You can see here on the beam at point C, one additional moment is given. You can see this 20 kilonewton into meter. See the problem. Determine the value of load W if support reactions are equal. Also draw shear force diagram and bending moment diagram for the beam loaded as shown in figure. First of all, you have to determine the value of W. The condition is given, support reactions are equal. That is very, very important. Now see this diagram. The problem is from May 2015 for 10 marks. See this diagram. At point A to B, uniformly distributed load is given. That is 20 kilonewton per meter. At point C, the additional moment is given. You can see this additional moment. That is 20 kilonewton into meter. So at point E, W kilonewton is acting vertically downward. See the types of supports. At point A, hinge support is there. At point D, you can see roller support is there. The contact surface of this roller is horizontal. Here, RAX and RAY, two reactions will be there. You can say RD, there will be a one vertical reaction. Here, first of all, we have to find out the value of W. We know that the first step is to find out the support reactions. So there will be a vertical force, that is RA. Here, one more vertical support, that is RD. Now, by applying the condition of equilibrium, the first condition of equilibrium, that is summation of moment about A is equal to 0, anti-clockwise negative, clockwise positive. You can see the assumption, that is clockwise positive. So here, first of all, you have to start from left. See, RA is passing through the same point, so the moment will be 0. Now, this 20 kilonewton per meter. So first of all, you have to convert into equivalent point load. So 20 into 4, that is 80. And it will act vertically downward at a distance of L by 2. Now the length of this UDL, that is 4 by 2, that is 2. So it will act here. So, and it will move in the clockwise direction. So 20 into 4, that is equivalent point load, into 4 by 2, that is perpendicular distance, minus this additional moment is given. You can see this additional moment, that is 20 kilonewton into meter. Given condition, that is anti-clockwise, so minus 20, that is very important. Not multiplied by the distance, because already here 20 kilonewton into meter, it is already multiplied by distance, so only minus 20. That is very, very important point in this problem. Now next, RD will move in the anti-clockwise direction. So minus RD into perpendicular distance, that is 4 plus 2 plus 2, that is 8, plus W will move in the clockwise direction. So plus W into perpendicular distance, that is 4 plus 2 plus 2 plus 2, that is total beam from A point to this W. Total perpendicular distance is 10. So W into 10 is equal to 0. In this equation, two unknowns are there. First one is RD and another one is W. But we know that RA is equal to RD is equal to R. because support reactions are equal, already given in the problem. So here two unknowns are there. So 8R is equal to 140 plus 10W. You will get this equation. After that, you can take R is equal to 17.5 plus 1.25W. That will be the equation. In terms of W, you will get the value of R. It's the very important equation. Here two unknowns. First one is R and another one is W. So the next and very important point, that is summation of Fy is equal to 0. So here Ra moving towards upward direction. So positive Ra plus Rd is also positive. So plus Rd. Now the downward forces, 20 into 4, you will get 20 into 4 minus, you can see the W, minus W is equal to 0. Here again, you know that Ra is equal to Rd. So you have to put Ra is equal to R, Rd is equal to also R. So you will get 2R is equal to 80 plus W. Now here we have the value of R in terms of W. So instead of R, you have to put that value. Now in this entire equation, there is only one unknown, that is W. After simplifying, you will get the value of W, that is 45 upon 1.5, that is 30 kilonewton. Once you will get the value of W, you can put the value of W in first equation. In this equation, you will get the value of R. Now you have the value of W. You will get the value of R after putting in equation. The value will be 55 kilonewton. See, means now you have the value of W and you have the value of R. The next step, the second step, that step is also important to calculate shear force calculations. See, while taking in consideration shear forces, don't consider moments. Here only you have to consider shear forces. Already I told you how to calculate shear forces for every point from left to right. For every point you have to write just to the left and just to the right. For A, B, C, D and E. So you have to write for shear force at point A just to the left, shear force at point A just to the right, shear force at point B just to the left and just to the right. Similarly, shear force at point C just to the left, just to the right, shear force at point D just to the left, just to the right. You can see shear force at point E just to the left and shear force at point E just to the right. And after that, you have to calculate all the shear forces. At point A, you have to consider just to the left. The cursor is here. Consider left side forces. There is no any left side force, so value will be 0. At point A, just to the right, 55 kilonewton is moving upward. So the shear force at point A just to the right, it is 55 kilonewton. At point B, just to the left, you can see here. Again, 55 is moving towards upward direction, minus 20 into 4. So answer will be minus 25 kilonewton. B just to the right. See, at point B, there is no any force, so the value will be same. So at point B, you will get only one answer. Means for just to the left, just to the right, you will get the minus 25. Again, from B to C, there is no any force, so the value will be same. For just to the left, just to the right, the value will be minus 25 only. But whenever you will come at point D, just to the left, again at point D, just to the left, the same value, that is minus 25 kilonewton. Whenever you will consider D just to the right. Now here, plus 55 minus 20 into 4 plus 55, the answer is 30 kilonewton. Here, D just to the right. Now E, in between D to E, there is no any force. So the value will be again remain same, that is 30 kilonewton, and E just to the right. 30 minus 30, the answer will be 0. You can see shear force at point A just to the left will be 0, and shear force at point E. Here shear force at point A just to the left is equal to 0. Shear force at point E just to the right is equal to 0. Now you have all the values for shear force calculation. Now the next and very important term, that is bending moment calculation. See, here the important point at point A and at point E will be 0 because these are the ends. Here you have to calculate at point B, at point C, and at point D. See, at point B means here, again there will be a sagging and hogging concept. 55 is moving, the 55 kilonewton is in the upward direction. So 55 kilonewton will move in clockwise direction. It is at left to the section. So 55 into 4 minus, see, 20 into 4, that is intensity of equivalent point load, and it will act at a half distance, that is 4 by 2. So minus 20 into 4 square by 2 is equal to 60 kilonewton into meter. See here, first of all, first see 20 into 4, that is the intensity, into 4 by 2. So 4 into 4, we have taken 4 square by 2. And why we have taken minus sign? Because it will move in this way, that is anti-clockwise. Section is here, and left side force is moving in anti-clockwise direction. So minus 20 into 4 square by 2. Say at point C, this is very important point from this problem. Here the additional moment is given. So first of all, you have to calculate C just to the left and C just to the right. If additional moment is given, if this type of additional moment is given, then you have to calculate just to the left and just to the right. You can see the major change. It is bending moment at point C just to the left, bending moment at point C just to the right. Here just you have to calculate by using regular process, means 55 into 6, so moving in clockwise direction, that is sagging condition. So 55 into 6 minus 20 into 4, that is the intensity, and the distance from C point, 4 by 2, that is 2 plus 2, that is 4. So into 4 is equal to 10 kilonewton into meter. See, whatever may be the answer, you have to take just to the left, that is 10. Here minus, they have taken additional moment, that is minus 20. So answer will be minus 10 kilonewton into meter. You can see here, just to the left and just to the right. Now the next, bending moment at point D. You can take bending moment at point D. Here you can consider either right side or left side. You can consider right side because in the right side we have only one force. So the answer will be minus 30 into 2. Minus because the condition is hogging. So minus 60 kilonewton into meter. See, according to this, you have to calculate. You have to draw shear force diagram and bending moment diagram. You can see here at point A, 0 and 55, at point B, that is minus 25, at point E, just to the left, just to the right, that is minus 25, at point D, that is minus 25 and plus 30, at point E, that is 30 and 0. See, below the UDL, there will be an inclined line. In between B to D, there is no any force, so the line will be straight. In between D to E, there is no any force, so line will be straight. can see below the UDL there will be a parabolic curve. After that, below this straight line there is an incline. Due to the additional movement, you can see here, due to this additional movement there will be a straight line. If any movement is given, additional movement is given to you, then there will be a straight line. At point C here you will get C vertical line. The remaining things are same. At point D you will get movement. At point E, that is 0. You know how to draw SFD and BMD. Here you can see the maximum bending moment. We know how to calculate this point. Shear force is equal to 0. So 55 minus 20x is equal to 0. You will get the value of x. Here you can see, you can extend this point here. So here shear force is equal to 0. So 55 is moving upward, minus 20 into, we don't have this distance, that is x. So 20 into x is equal to 0. You will get answer x is equal to 55 upon 20, that is 2.75. So this distance will be 2.75. And where the shear force is equal to 0, at that point, the maximum bending moment. So you can take this point here and you can calculate maximum bending moment. We have x distance. So by taking this x is equal to 2.75, you can calculate bending moment, that is 55 into x into 20 into x by 2. Here we have the value of x. You will get the maximum bending moment, that is 75.725 kilonewton into meter. It's a very simple problem. If you will solve this type of problems, automatically you will get the maximum confidence and you can solve any problem very easily. Now I have completed this concept if the additional moment is given. Thank you very much.